Hello everyone. Today we're going to present you the application VISAB, which stands for Visualizing Agent Behavior. As the name already indicates, VISAB is a tool to visualize AI behavior conveniently. VISAB was developed within an IT study project for the working group IIS at the University of Hildesheim and under the supervision of Dr. Pascal Reuss and Professor Dr. Klaus-Dieter Althoff. VISAB is intended to offer support for multiple AI scenarios in the future. As of now, two games can be visualized in VISAB, CBR Shooter and Settlers of Catan. Both games were created with the intent of developing AI agents that face off in a fierce competition against each other. Due to the core competence of CBR as a paradigm of artificial intelligence at IIS, a strong focus on how the respective CBR agent implementations are performing against other agents was given. CBR Shooter is a real-time first-person shooter where two players, or agents, try to get the upper hand in a classic deathmatch game mode. In addition to simply finding and shooting each other, the agents can pick up health items, ammunition crates, as well as additional weapons to improve their chances to win. Settlers of Catan, in contrast to the CBR Shooter, is a round-based strategy game directly derived from the original board game. In this game, the AI bots aim at getting the upper hand in an economic manner. By collecting resources and building up their realm, victory points are gained and decide who wins the game. In order to support developers on debugging and analyzing their agent implementations, we now proudly present VISAB and its included toolset. VISAB is an easily portable Maven-managed Java application with cross-platform support for Windows, Mac, and Linux. Its main purpose is to receive, analyze, and visualize game data, particularly in order to expose CBR agent behavior. Due to the fact that VISAB is capable of illustrating the wholesome game information, visualization of any other kind of player instance, such as other AI variants or even a human player, is also given. Let us now dive into VISAB by showing you a little demo of its workflow. When the user starts up VISAB, the home view, which contains a file explorer out of which it is possible to load, select, and visualize specific game data files, is displayed. This file explorer operates on the dedicated workspace of VISAB, which is used to store game information files persistently after the data transmission from any game is completed. After the user has selected a file and clicked Visualize, the game-specific views open up and can be easily accessed within a well-structured tab pane to take a deeper look at the underlying information of a certain match. The file's meta information, such as number of rounds and general player or weapon information, is directly presented in the first tab. The next tab contains the statistics view, which shows a comparison statistics table in which the user can gather more detailed information about how the individual agents perform within the game session. Very next to this table, the user will find the comparison graph section, which will visualize a row of the table when you press Show in Chart. Furthermore, pie charts in the bottom half of the view will illustrate the plan usage of the specific agents. Given the fact that the statistics view aggregates game and player information in a rather static way, the user may feel the need of re-experiencing the match to clearly find out at which specific moment in a game a certain behavior occurred. To address this need, the third tab contains the replay view, which provides a visual insight into how the matches went down in detail. In order to help the user to focus on the relevant information of the game match, the replay view offers an abstracted view of the game, showing the behavior of each agent in detail. To optimize the distinction between the players, color coding for each player-related visual is performed dynamically. In this case, a session of the CBR shooter is visualized. Drawing the agent's waypoints to inspect the pathfinding logic, showing plan changes, and deaths are useful features of the replay view to dive deep into the agent's behavior. Furthermore, it can be seen if miscellaneous game items were picked up or which attribute values a player has at a specific time in the game. In this way, the user can detect nuances and/or anomalies in the agent's behavior a numerical statistics view would have not offered. Moreover, a frame slider offers full control of the session's data and can be utilized to rewatch certain situations over and over again. It is possible to play or pause the session if the user wants to let it play out without further inspection. The game speed is also adjustable. To ensure improved clarity, information can be hid and shown, which is useful if one wants to focus on certain aspects of the game, such as the position of the agent's deaths, for example. All visuals shown in this view are originally sent by the respective game to ensure that the replay view has a consistent look and feel with the real game. Let us now take a look at how VISAB handles receiving data from multiple machines and multiple instances. For that, we will open the session overview out of the home screen. As we can see here, we have several running sessions that are currently communicating with our VISAB tool. VISAB's event-based architecture allows us to receive data simultaneously from multiple sessions of the same game and other games as well. As you can see by the IPs, the game itself does not even have to run on the same machine as VISAB. Additionally, we're able to visualize a currently active session and take a live look into how the game is played out. As you can see here, the visualization functionality remains the same and has no drawback when done live. Upon closing a session, the file is stored in VISAB's workspace and can be accessed immediately out of the session view, but of course, also from the home view's file explorer. Active sessions can be aborted by the game itself, as well as by VISAB if a certain timeout criteria is met or the user forces it by button press. Inactive sessions are marked as such and can be cleaned up upon one click. The communication between VISAB and the games is realized using an HTTP protocol-based web API on VISAB's side, delegating the received information in an event-based manner. VISAB acts as the server and the games as clients. Unity-based games may also make use of the so-called VISAB connector, which provides a C# interface for the web API. As already mentioned, the needed game visuals, including the map itself, are extracted dynamically from the game sessions and are being visualized in VISAB's replay views. The initial version of VISAB only supported the CBR shooter, and one of our goals was to integrate Settlers of Catan into it. We did not only achieve the integration, but also enrich VISAB with a code infrastructure that is easily extendable by other developers in the future to support more games or even other AI scenarios. Generally, VISAB has been overhauled in terms of its graphical interface, now powered by the MVVM pattern, and various user-friendly functionalities have been added. If you feel interested, please visit VISAB's open source project on GitHub.